Welcome everyone. Thank you for joining us today's webinar. My name is Yusuke Mori, Deputy Executive Director of IAMU. Today we are happy to organize a webinar on IAMU Biofouling Network, environmentally friendly antifouling solutions. So this is one of the IAMU funded research project for fiscal year 2024, meaning it's an ongoing project, and coordinated by the Liverpool John Moore Universities, UK, with a cooperation with the Constanța Maritime University from Romania, Istanbul Technical University, and Ordu University from Turkey, and also Academy of the Maritime Education Training University from India. So this webinar outlines the general information about biofouling and the rationale for why IMU member needs to understand antifouling. So just a little housekeeping before we get started. Please mute your microphone during the presentation. If you have any questions, please ask them during the Q&A sessions. You can write the questions in the chat box. There are some people behind to pick up your questions all the time. But you have given the opportunity to speak. Actually, this is not webinar platform. We are using the meeting platform. So maybe you are allowed to speak afterwards. So now it's time to over our presenter, Dr. De Simone. Floor is yours. Please go ahead.
Thank you for the invite. So good morning to everybody, or good afternoon. And for some of you, it will be also an evening. So good evening as well, and maybe in the night. Yeah. So welcome to the webinar by the IAMU Biofouling Network. We are looking into presenting more. So in the next one, after this one, I just want to point it out. It is actually in about 3 weeks, the next one. And I hope today, though, that you're all well and excited about the topic, environmentally friendly anti-fouling solutions that we are presenting today. So my name is Dr. Simone Dürr from Liverpool John Moore University, and I will take you through today's webinar. Our schedule today is to introduce the house rules, then the presenters, and then starting the presentation. So at the beginning of the presentation, we will actually be doing a short poll and continue then with the presentation. So that's after 2 slides. The presentation will be about 30 minutes and you can ask your questions. Feel free to post them in the chat or later on raise your virtual hand. Yeah, we will ask you then to present in the question and answer session after the presentation to read or to speak your question. We will answer your question to the best capability that we have. Yeah, but we are keen actually to facilitate this as a discussion between everybody. So not just between us in the network and you, one person, but actually also between the people that are here as audience. Yeah, so that's really our aim, that we have this really as an interactive approach. Yeah. So remember, please raise your hand then or write in the chat whatever you want. And it's super if you can contribute individual questions and we will let you know what when you can speak. We will close the meeting after 1 hour. And important, I also want to say that this is all recorded. Yeah. So if you don't want to be videoed, then switch off your camera. And also the questions will be recorded. So at the end, there will be then a survey about the webinar available for you. And please fill that in. It's very short and it will help us then to present more interesting topics for you. Yeah. Now, next step now is basically that we have the presenters them introducing themselves. So I quickly introduce myself. So as I said, my name is Dr. Simone Dürr. I'm working in biofouling, anti-fouling since quite a few decades now. I'm currently working at Liverpool John Moore University as a senior lecturer in marine biology. And next to me, we have actually Bogdan, and Bogdan will introduce himself.
Thank you, Simone. My name is Bogdan Hnatiuk. I'm professor at Constanța Maritime University. I have a PhD degree in electrical engineering and another PhD in plasma physics from Orléans University in France. Okay, thank you.
Yeah. Thank you, Bogdan. Good. And our third presenter is Dr. Sheila Conlon, and she will introduce herself.
Hello, I'm Sheila. I also work at Liverpool of John Moores University. I've been in the biofouling, anti-fouling business, again, similar to Simona, 25 years. I'm interested in looking at experiments, testing fouling and anti-fouling solutions that are put forward in a laboratory-based systems. Thank you.
Thank you, Sheila. So we are starting now with the actual presentation. So let me just get that up, basically. Let's have a go. So today we are actually working on anti-fouling and are there environmentally friendly solutions for that? So as you know, it will be myself, Sheila, and Bogdan who present. And I want to just point out we are part of the No Foul project, and you can email us under that email address there that you can see. Good. So I also wanna remind you, if you haven't been to one of our webinars, or I should say the other webinar, that we are looking actually for more members in our biofouling network, which is under the umbrella of IAMU. Yeah, and so Iske totally is in the network as well, and Takeshi. So we're hoping, and Shigemi, yeah. And so we're hoping that most of you now, or all of you, actually sign up, that you are in that network, so we can collaborate more in other things, not just the webinar. That we can look maybe at funding, that we can look at training, which is very important for you if you're mariners and stuff like that. It's important that you learn more about that, or that you actually can with us together train your own students. Yeah, so there is loads of capability there, options that we can do, and we should exchange all that. Yeah, so please consider to sign up, and you can just do that by email us again at this email that you can see here in the middle, IAMU nofoul@lgmu.ac.uk, and you will reach us and we will reply to you, and there is no other requirement there other than that you are a member of IAMU, or your university is a member. Yeah. Good. So if you have got questions about that as well later in the questions and answers, that's also an option where you can ask. Okay, good. So the presentation, what we're doing there today is about, first of all, we need to bring everybody at the same level. So we need to find out what is biofouling and why actually you as IAMU members need to really understand anti-fouling. Yeah. That follows on then with what do you really need to understand that is required for environmentally friendly anti-fouling solutions, which is currently really the fashion thing, you know. Obviously, it's important. So we're looking there in the past, what was required in the past regarding environmentally friendly, what's now, and what potentially could be more in the future. So we're looking then particular on the current anti-fouling solutions. We have selected some solutions that we thought maybe in the future will be quite interesting and or are a bit strange. Yeah. So we understand them a little bit better, because obviously these kind of companies, they will be also trying to come to us and sell that and so on. Yeah, and then also we want to see in the far away future, what will be there in the pipeline regarding environmentally friendly anti-fouling solutions. After that, we have the Q&A, and there's at the very end a short survey as well. Okay, good. So what is biofouling actually? So the colonization process or the community of sessile organisms on a solid surface, or even on an on an organism, that actually is biofouling. And this goes back to Martin Wahl from Kiel. Actually, he was my doctor father, 1989. And this definition is still valid. However, in industry, they see this a bit more simpler. Yeah, so it's basically just the unwanted growth on artificial surfaces. Yeah, so you pick yours what you want if you're a biologist or an engineer. Yeah. Okay, and look at these beautiful barnacles there. You even see here these, don't know if you see my arrow, but there are even just metamorphosed barnacles there. And while these are adult ones, yeah, so it's quite interesting. And this here is the larvae of the barnacle, the cyprid larvae. And it looks just like a rice corn, and that will metamorphose then into that little barnacle there. Yeah, just as a side effect. Yeah. Okay. Now, why do we actually need anti-fouling? Okay, we have talked about what is biofouling. You know it from your ships and stuff, but why really do we need anti-fouling? It's obviously for the ship in terms of materials, material fatigue due to corrosion, which is also facilitated by biofouling. But there's also the big thing with hydrodynamic drag. You know, if you have got on your ship hull loads of biofouling growing there, your ship will not be able to go so easily through the water, and so that means you also need more fuel. Now, nowadays we have obviously an issue with emissions. So the more fuel we need, the more emissions, and therefore in the end we have then an acceleration of global climate change, and we cannot do that now, obviously. Another thing is invasion of species, which might impact on our diversity locally, and then therefore also globally. Now, we also have issues with, for example, sensors. Our ships, they have loads and loads of sensors, and they might also be impacted by macrofouling, but more likely on biofilm. Yeah, and it's not easy to put coatings on there because they impact actually on the measurements. And therefore, this is a big issue, and a very specialized solution is needed for that one. Often items get beyond repair. And finally, also the load of weight that this ship actually also carries. Now, I haven't got actually no weights for ships, but I can tell you that, for example, in aquaculture, if you have like a salmon cage, and that normally maybe weighs about 1 ton, after a season, there's over 3 months in the summer, it's easily increasing to 11 tons. Yeah, and you can imagine that if your ship stays somewhere static, it will collect loads of heavy organisms, yeah, over time. So all of that means economic costs, environmental issues, climate change, invasive species, and pollution, big issues. Yeah. Okay, so that's why we have anti-fouling. The other part of that is that actually some of this is also regulated. For one, we have got the resolution MEPC 37880 from July 23 updated. So that's basically the IAMU biofouling guidelines. So these are international standards for biofouling management. And so here in this update, they were addressed the antifouling systems again. Then the greenhouse gases, invasive species, in-water cleaning, because that when you do in-water cleaning, loads of fouling actually just falls down from the ship and is on the ground then. And these organisms, many of them, they can just continue being alive and can settle somewhere else. And so in-water cleaning was mentioned because of that, to find solutions that it is not getting onto the natural environment. Training was also mentioned. That's very important, as you see there below, Annex 17 on pages 21, 22. It's basically a requirement that people get trained in these areas of shipping. Yeah. And so that's important that it gets into the syllables because that's still neglected currently. So these kind of international guidelines, they go normally into national legislation, and but this takes a long time, and that's why it's a good thing if actually shipping companies already consider that now and not later. Good. Now, when I prepared for this webinar, I suddenly found out that actually there's not a real definition for environmentally friendly. So I collected that together, the information, what I actually got. So if you look at the Oxford Dictionary, it's basically not harmful to the environment or helping the environment. That's basically what environmentally friendly means there. Now in the United Nations, they aim for sustainable future. Sustainable is basically also environmentally friendly because you want to help the environment, you want to be not harmful. So, and therefore the future is sustained for future generations. Yeah. And that is kind of also then the environmentally friendly definition. And you see that also in the UN 17 Sustainable Development Goals, the SDG. And I pointed out here two of those. That's CDG 13 and 14. So one is climate action and one is life below water. They are directly impacted on shipping, but we have got various others that actually indirectly, or rather more indirectly, impact on that as well. Yeah. So just for information, and please go and have a look at the Sustainable Development Goals. Loads of universities actually look at their research and their training and actually print out reports how that actually fits with their work. So I also then found out, you know, there's some aspects of what is environmentally friendly is already considered. Others are only just mentioned and by end users and policymakers and so on. So I listed here the ones with the ticks, that's basically that is considered or maybe mentioned in a regulation or so, but then there are big points where it's not properly brought forward. So what's actually already quite okay is the biocides. It's known, you know, what has to be done if you have biocides in there, how they dealt with. Then we also have the polymer coatings. yeah, there's particular the self-polishing issue. What is the problem there? Polymers are plastic, and therefore we also get microplastics from that, and that obviously that will get into the water column. Yeah, particularly with self-polishing. Another point is the collection of biofouling when cleaning. That's what I already mentioned, that this needs to be absolutely by innovation addressed. Now, two big things are in the room, or I should say elephants that are hidden somewhere, are hidden biocides. Yeah. So paint companies, they actually can hide biocides in their environmentally friendly coatings as catalysts. There are new compounds which have not been properly assessed for biocides because they don't have to if they are used as catalysts, but there are quite a few of these compounds that actually highly likely more efficient even or similar efficient like TBT, and they were not assessed because, as I said, they were seen as catalysts. And another point is also the biocides leaching. Okay, we know about that from coating there will be leaching these biocides, but how far away do they actually leach? Do they go into the proper water column, or are they staying within the boundary layer? That's basically a 2 mm layer over your artificial surface, be that the ship hull, for example. Yeah, and then the other thing is new biocides that are put into coatings. The problem is there that they might be seeing as okay or even environmentally friendly, though how far can a biocide be environmentally friendly? But the problem is that some of those will be actually create new compounds by in operation. So for example, a group that is very worrying group basically are the halogens. Yeah. So if you create from let's say fluoropolymers, you easily might get new compounds when you put that in operation. Okay, so we also have seen that there is a change in awareness about what kind of requirements we need for environmentally friendly solutions. So if we look past many decades back, basically now, actually, it was the TBT. In the beginning, we didn't find that is a problem. But now, a few decades ago, this was found out, and so we have the convention about this, and so it's prohibited. Yeah, so that's a good thing. But what happened then? We didn't realize that actually biocides, other biocides might also be a problem. For example, like copper. That followed on to also then the dependence of self-polishing coatings. So then we have issues with even more plastic impact than in normal coatings. Now, past that in time, we seen then that actually some countries actually took the biocides as not such a good idea. So, for example, Sweden, they in part of the country, it's not allowed to have copper in the coatings. Later on, this led then also to a more foul release coating, so silicon, fluoropolymers without toxin, which was a good thing. But this then later changed basically, and that's the last point now, I just mentioned this now, that actually now these coatings are actually toxic, yeah? Be this direct with biocides, be this with catalysts, and this was on request by shipping industry. Now, in between these two happenings there, we also have got that the nanotechnology came up. So that was after 2000. And the great thing, but what nobody thought about is oh, they are actually biocides. And loads of people still develop those, not realizing that actually they have to be assessed like biocides, and that can take, you know, up to 10 years or longer, actually. Yeah, and more recently now, though, more better ideas are coming up for cleaning. So basically going back to the olden times. So just a development of awareness over time, I wanted to show you there as well. So you understand more what we're talking now about. So yeah, so let's talk now about actually new environmentally friendly anti-fouling solutions. Now, one very interesting compound, I want to show that to you. Now, this is actually called Selektope, and I have got the compound seen here as a little graph there. And this is actually nothing else but ketamine. Yeah, ketamine, which is used for horses, and it is also a what Sheila always said is a recreational drug. Yeah, so naja, people think that, okay. Yeah, I don't know, I don't mean Sheila. No. Yeah, so but Selektope is quite interesting. It really hinders the larval settlement, particular of barnacles. And what they do, they make them completely mad, so that this cyprid larvae, basically, that is swimming around in the water column, get so mad that they don't stop swimming, and they forget about that they actually should be settled down on the surface. Yeah, and that is quite amazing. Yeah, and so this could be one of the big coating ingredients in the future, I would say. So it is already available as a paint. Yeah. So the company is actually called Selektope, and it's in Sweden. Yeah. I'm not advertising that. Yeah, this is not advertisement at all. It is just, I'm talking about that compound. Yeah, and it is amazing. Yeah, if you think about it, and yeah, totally new thing. Yeah, but you still have then the plastic and microplastic issue with that, obviously, because it needs to go into a standard coating. Yeah. Good. Now, there are options now, which, and this is not just the only one that I'm presenting there, but it is one of the older ones. It's more material than a coating. Yeah. So you have got your ship hull, and this not coating but material is actually sprayed thickly onto the hull. Yeah. I'm speaking here particular about EcoSpeed. It's a vinyl ester resin base, and it contains also then glass platelets. Now, I have got friends, they work in British and Arctic survey, so they are involved with that ship there, that you can see there, the RRS Sir Attenborough, and that has that coating on there. Yeah, but beforehand, there were, since in the last 30 years, there were icebreakers already with for the Arctic and Antarctic who had that on already. It is obviously environmentally friendly, yeah, though relevant. There's still the vinyl, yeah, in there. It's strong and lasting, yeah, not like the coating, scrape, yeah. No. But what it needs regular cleaning. Yeah, so I was told about every 6 weeks you need to clean it. Yeah, but as we later found out, it actually also is will be new ways of cleaning. Yeah, so there are no biocides leaching, and there are no plastic issues. Yeah, so that's quite interesting stuff there. We have then also acoustic. Yes, acoustic and ultrasound. And Now, they can quite well also inhibit barnacle settlement, has been shown. It reduced the settlement, and depending on the pressure of the acoustic. It's not selective, so it needs actually more data, because currently it's more small scale and more dominant with lab studies and so on. But there are loads of companies who sell it, and this see here a little thing how this all of them actually look like that. So definitely more research needed so that we understand that it really doesn't impact in a different system than basically in the ecosystem. Yeah, so basically. So no biocides leaching and no plastic. Electric fields. That's an interesting thing there. There is not much looked into that, but you can buy that as well too. And I myself actually have seen, and I know Sheila as well, that an electric field can actually impact, for example, muscles. We've seen that. So it looks like the muscle seems to feel it's like burned or something. Yeah, it looks quite interesting. Yeah. Okay. But we need more work with that. Not us. We don't do that. Yeah. Okay. And then a really funny thing is the air bubble option. Now that has been done already for quite a while in our aquaculture section. And so it looks like that shipping has taken that on as well. I just didn't get any photo about that for shipping, but I got it for aquaculture, what you can see there. So if you look at this white area there, that's the bubbles basically. And these are jellyfish. In aquaculture there, we're scared of the jellyfish because the fish are over there. And so that's good option there. Don't know how good it really is in shipping. Yeah. But if it gets more data and we can get to learn more about it, who knows? It certainly wouldn't be biocides and it wouldn't be plastic. Yes, and now I want to quickly give forward to Bogdan, who presents something.
Thank you, Simone. So just a few words about the non-thermal plasma produced at atmospheric pressure. Here we are talking especially about preventing the biofouling, but I can confirm you the non-thermal plasma could be used for the conditioning of the naval surfaces, but also for the removal of the biofilm. Just a few aspects about the conditioning of the surfaces, of the naval surfaces, in order to apply another method to protect these surfaces. So the non-thermal plasma is obtained by electrical discharges into electrochemical reactors. They produce electrochemical active species able to modify the properties of the solid surfaces. What are these modifications? Firstly, a decrease of rugosity of the surface. This decreasing of rugosity will determine a more homogeneous surface, an increasing of microscopic atomic forces, changing the degree of the hydrophilicity of the surface. And at the same time, we observed for the metallic surfaces a modification of the chemical concentration, indicating the possibility of an increasing resistance against corrosion, but we need more tests in order to confirm this first hypothesis. Here we have two photos of gliding discharges. The gliding discharges could be supplied from an autonomous power supply. So it's not the production of this non-thermal plasma is not directly linked to the net to the power supply of the net from the network. At the left, we have a gliding arc with gas flow in order to provide the gliding of the discharge. On the right photo, we have a mini torch also using a gas flow. Another possibility of non-thermal plasma is the use of dielectric barrier discharge. Here we have a photo of this discharge. Usually the DBD is easier. The DBD is providing a more homogeneous treatment of the surface, and it is easier to be produced because this type of non-thermal plasma does not need any gas flow, so only the metallic electrodes and a source of high voltage power supply. The advantages of these methods: there are no biocides leaching, no plastics of microplastics, and the electrochemical active species actually they have a short lifetime, so the effect of these treatments are limited, and for this reason there are no environmental issues using this type of non-thermal plasma. Thank you.
Thank you, Bogdan. And I want to hand over then now quickly to Sheila.
Thank you. So I'm going to talk a little bit about textures as a novel solution, environmental friendly solution to fouling. And mostly they are in the past have been based on mimicking existing biological surfaces that show either no or little fouling. For example, at the top here, we've got some images of shark skin, which has been mimicked by a surface called sharklet. The idea behind the textures is to try and make the surfaces unattractive for settlement. So settling organisms will decide not to settle. This is really impacted by the scale of the texture. So the image that you can see with the bacteria in the barnacle larval settling has the same scale of the structure of the surface, the texture on the surface, but hopefully you can see that a barnacle cyprid might find that pretty unattractive. Its settlement pad hasn't got anywhere to stick well, whereas a bacteria will actually quite like that scale of surface and may well settle in an increased amount. So you may well need multiple levels of scale in order to work against different sized organisms. Another way that textures work is they change the hydrodynamic flow across the surface, often resulting in areas that are high in turbulence and therefore have increased shear forces on the organisms. So that can remove the organisms or prevent them from actually touching down to settle. And finally, the last idea of textures is to reduce the adhesive strength, because an organism doesn't have a level surface to attach to and has only little points of attachment happening, and that results in a weaker attachment strength. Next slide, thank you. So these have been shown to be relatively effective. Certainly in terms of biofilm, they reduce biofilm. In terms of the macrofouling, we see a reduction in the earlier stages of macrofouling, so the larval settlement stages. So up to now, it's mostly been using almost a direct copy of biological systems that have already been seen to work in the biological world. But increasingly, we're engineering microtopographical surfaces with biological systems more as a starting or an inspiration point, and developing it much further. Also, changes that are happening is previously, most commonly, in fact, all of our textures have been produced using lithography or molds, using compounds such as PDMS, polycarbonate, epoxy. I mean, the list is very long, but they use these relatively restrictive methods to produce the texture. Within No Foul at LJMU, we've been using a nanosecond fiber laser on to stainless steel to produce our textures in a much more controlled system, and we can do much larger scale. So we've done upscales and demonstrated that just recently. One of the key issues with textures is actually the design of the texture itself. So determining what kind of texture you would like, and then translating it into a texture that can actually be engineered and produced with whatever technique you're wanting to use. Because textures tend to be long lasting and don't need to be reapplied like coatings, they're ideal for niche areas or areas that are difficult to get into to recoat. Obviously, the benefits are we don't have any biocides leaching, and we don't have plastics and microplastics on the hard compounds that we perhaps particularly use with the laser.
Thank you very much, Sheila. Okay, so we have only a few slides more. So it's now about the removal of biofouling. So the new old solution, basically, which always is no biocides, no plastics and microplastics, but it brings something new because the introduction of invasive species as you take it off from the hull. So we have got, we could have done like 100 slides just about manual removal, which we didn't. So we put it into one. And you can start there from mechanical scraping over power washing, over ROVs, AUVs, and also even now laser radiation and biological control. But in all of that, it is labor intensive, it costs, and it's highly effective though, but obviously it can be damaged, the coating, for example. It generates large amounts of wastes, and therefore the invasive species issue as well. Some of the species can survive, yeah, they not necessarily get killed by that approach. And yeah, so we have the accidental introduction of the invasive species, but also parasites and pathogens. And so for this, we need much more data. And there's a lot of more work to do, basically. So that brings me to the end now with the conclusion of the presentation there. It's basically that we never can completely avoid biofouling. Yeah, it's live, and we will always find a solution around your solution. We need to be aware of the IMO regulations. It's important that training is supplied for seafarers about all of that. There are, as you see now, new emerging solutions that can be environmentally friendly. And some of these approaches also tend to be not coatings. And we think that in-water cleaning is one of the big things that will be coming up now with all the robotics and machine learning. And hopefully also with better holding compounds, containers basically for the biofouling that you take off, including pieces of the coatings. Yes, so further considerations when selecting new antifouling options and their environmental harm need to be evaluated really, you know, in particular new biocides, their production of new compounds in situ, etc., etc. And yeah, so that basically is our conclusion about that. And I just want to point out again, we need to discuss all this in more detail and not just in 15 minutes. And so please get in contact with us, and we put you in the network. And we can set up some discussion rounds, basically round tables. But I want to open now the session for questions. And I think there were already some items in the chat. Sheila, what do you see there?
Yep. So there's Esther Rodriguez Alvera. You had a couple of questions. Did you want me to read them, or do you want to read them out yourself?
It's okay, yeah, but I don't know if you can hear me well.
Or we struggle to hear you. Yep.
Yeah, okay. I was just wondering if these coatings or options can be used also for the ballast water tanks, or they should be different.
So I could hear it. Did
Yeah,
you
so
see it?
it was asking if some of the coatings that we talked about, could they be used for ballast water tanks? Is that, yeah.
Okay. So, okay, with a ballast water tank, you always have a problem that you only can paint it once when the ship basically is built. Yeah. And so therefore coatings are not lasting this long. The biocides won't lasting this long. We cannot paint them again normally when you get to reclassification every 5 years. So that is a weakness in a ship. Yeah. I don't know if anybody in the audience already has some more information, if there are new options now for coatings in ballast water tanks and pipes. But as far as I know, this is not, they applied it there, but it will not last long. Yeah. And so you actually breed your biofouling and your invasive species in your ballast water tank. That's why there is treatment. Yeah. Did you have another question, Esther?
Yes, I had, but it was addressed during the presentation. It was about the microplastics in that alternative paint that you were mentioning.
Sheila, did you hear that?
Yes. So
Yeah,
it was answered. She had a question, but it was answered already in the presentation about the microplastics in some of the alternative paints. So Prasanna, I'm sorry, only Kumar is coming up with an R, so I know you have a longer name, so my apologies if I've missed your surname. Is asking a question on chat. Do you want me to? Can you unmute your?
I'll ask. No issue.
Brilliant, thank you.
Yeah, I would like to know: is there any technique available so that I can measure the thickness of fouling from inside the ship?
Ooh,
good question.
That would be great. That would be great. So let's start a project on that. Yes. Yeah. So that's exactly these kind of ideas, they need to come out into the world, and then we, by interdisciplinary research, we can actually find a solution for that. Yeah. But if we don't never hear about these things, then we never consider it. So this is actually a good thing, what you say there. So certainly sign up, please, for our network so that we can discuss that more. And Esther, you as well, please. Yeah. Mm-hmm.
Sure. Thanks.
Yeah. Yeah.
Oh, Yusuke has a question.
It's not a question from my side, but I really want to ask you about, elaborate a little bit more about, the benefit. What is the benefit to be a member of this crowdfunding networking? Because you are asking the people to join the networking, but if they feel like, there's no benefit for them to join the networking, then nobody join. So can you highlight a little bit more about, what is the benefit to be a member of the networking?
Okay, so let's just go back to that. Oops, no, not this one. So basically, you see here actually the benefits already. So training, you can get training from us or with you. Yeah, collaborations. We can like these ideas that they were put out in the open there. Oh, we need that. We need to find out from inside the ship if there's biofouling there. Yeah. So we the scientists here, we want questions from you, and we can then together sort that problem out. It's collaboration, it's networking. Yeah. maybe some other ideas. Other people already have the solution for that, or just working on it in our IAMU member universities. We just don't know about it, you know? And or maybe somebody has half of the solution and another person has the other half of it. And so they should come together. But they will not come together at an AGA, yeah? They will only come together in a network that has the same topic, which is biofouling in this case, yeah? So that's really important. Also, it's important to understand biofouling much, much more, because we learn more every day about it, and we can basically give you that information, and you maybe can also give to people in the network your information. Yeah. So it's an exchange, it's a transfer of knowledge. Yeah. So it's a transfer, but an exchange, yeah? And that's why it's so important. So we want to have experts in there, academics, but mariners and seafarers as well, yeah? So because that's the groups that need to work together to actually make this much better and make it working, you know, and cost effective, yeah? Exactly, yeah? Have I forgotten any benefits about that now? Sheila, any ideas?
I would
Bogdan?
say it also brings us together to perhaps apply for grants together. So
Yeah,
with the new
exactly.
ideas that are coming forward, gives us more strength and power to request money from
Yeah.
places.
Yeah, exactly. Yeah, maybe from ISKIM. Yeah.
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 And
Maybe yes, but maybe no.
No,
Who
no.
knows?
No, we're looking more maybe an EU grant, you know? We can look at that. Yeah, exactly. So that's why, but you need to be in that network. Otherwise, we cannot get this going, basically. Okay, any more questions then?
Yeah, I'm sorry. Maybe I would like to raise another question, but it's somehow related to the first question. But in the future, maybe it's a good idea to organize some, the workshop or conference dedicated for the specific topic, because your aim is working together to building some solution together, find a solution together. That means maybe you can organize the event or workshop or conference or whatever dedicated on the team on this specific topic, and you can call the expert and the interest people to the one place and to discuss more details about 1 day, 3 days or 2 days.
Exactly.
Because you already organized the workshop before within the teams.
That was last year within our project for 2 days. It was very successful, wasn't it, Bogdan? Because Bogdan is not an biofouling person at all, but I think you learned loads, didn't you? Yeah. He ran his own experiment now as well. Yeah.
Yes.
And but this was in person. Yeah. Obviously, for that you need funds. So maybe it's good to have as a start an online day or something. Yeah, that would be a good option. But for that, we need people in the network. Yeah.
Okay.
So that we know who we should invite, you know?
Okay. Within the IAMU community, we have like a working group on the simulator training. So they organize like a simulator instructor camp. So we are not, we are not sending the money to the participants, but they voluntarily join that simulator camp because they really interested in that topic. So maybe if your topic was so interested by our members, then you are not necessary to worry about the money. So many people are coming to the workshops.
Okay, yeah.
But anyway, thank you very much.
Maybe we can also have a working group on that. Yeah.
Possibly, yeah.
Yeah, who knows? But first, we need more members in the network. Yes. Okay, more questions.
So actually, Esther had a potential answer for Prasanna's question about working out the thickness of fouling from inside ships, suggesting that perhaps with the measuring of the reduction of speed, you can measure the approximate thickness to what extent the ship is fouled, and yeah.
Exactly. Yeah, that's what the officers already do anyway. Yeah, but that it's not super exact. Yeah. So
Yeah.
more a scientific approach to it, you know, maybe with sensors and stuff, that might be a better option. Yeah. A more exact one. Yeah.
Yeah.
What else do we have?
Alan Roberto? Alan Roberto? Oh, okay. So I'll read the question out then. How about the use of ICCP? I assume he means impressed current cathodic protection. Are they still an acceptable solution for reducing biofouling in modern applications?
This is more for the corrosion, isn't it?
Yeah, so the cathodic protection,
Yeah,
but it is supposed to also
exactly.
give a small amount of impact on the biofouling, I think.
Yeah, exactly, which is similar to the electric fields, basically.
Yes.
Yeah, yeah. But it obviously hasn't got a far reach. Yeah, I would say. Yeah.
Yeah.
Yeah. That's why they have coatings now. Yeah.
Yeah. Yeah.
Mm-hmm.
Okay. Another question from Juan. What other benefits can anti-fouling laser texturing provide?
Other than anti-fouling and foul
Yeah.
release, yeah?
Yes.
Okay. So I'm sure he is interested there in corrosion. Yeah, and
Sorry,
also,
Simone. I
yeah,
can reply.
yeah, you can
Okay,
reply.
really,
You
one
answer
of
your
these,
question.
yeah, one of these is, yes, first, the corrosion resistant.
Yeah,
We carry out some analysis with other type of texture, and laser surface texturing increase the corrosion resistance of the material. And addiction
yeah,
provide another
yeah,
corrosion properties of the material. In
yeah,
addition,
exactly.
the
I also want
friction.
to add quickly, Juan. I want to
Yeah,
add with that because people will now
okay,
think, oh,
okay.
why are we interested in corrosion? Actually, corrosion is often called from biofouling. Yeah, particular the biofilm is has a big impact on corrosion. Yeah, the sulfate bacteria in the biofilm are a big issue. Yeah.
Hmm.
Mm-hmm.
Yep. Yeah,
Yeah.
exactly. You have a biocorrosion. Yep,
Mm-hmm.
exactly. But
Yeah.
yeah, the corrosion is one benefit, but the laser surface texturing have another type of benefits for the seat. For
Mm-hmm.
example, reduce the friction and wear.
Mm-hmm.
You know,
Exactly.
this is
Yeah.
a
Yeah.
good point.
Yeah.
And besides, you can combine with paint to improve the adhesion of the paint.
Mm-hmm. Yeah.
This is a
Yeah.
several benefits. Okay,
Yeah.
only this.
Yeah. Yeah. Textures have loads of benefits. Absolutely. Yeah. Yeah. Okay. Do we have another question?
Yeah.
Sorry, Juan. Yeah. Thank you.
Alexandra,
Go on.
is that how? I'm sorry if I'm destroying your names. I
Yes,
really
yes,
struggle.
it's me.
Yes.
If
Oh, thank
possible,
you.
hello to
Hello.
everybody.
Hello.
Just a moment. My charge is slowing. Sorry,
Oh,
it's okay now. So I just want to ask you a question, which very often students ask me. Are there any studies and calculations of the proportions or percentages of biofouling, gains from hydrodynamic products and increased fuel or its increased fuel consumption or corrosion or engine failure, species invasions or something else? What mostly contributes to biofouling? Thank you. Are there any calculations?
Okay. So do you mean
Percentage,
like,
proportions?
so that is done as simulations, yeah, and modeling by the naval architectures, but they are just estimations because biofouling is you cannot predict.
Yes.
It is not possible, you know. It is like any life. It depends on what kind of larvae are currently available in the water column.
Yes.
It depends on where the ship is. It depends on how long the ship was not moving. In all these things, you know.
Yes.
So
Yes.
there are so many points there. It depends on the materials, everything. Yeah. And so all of that you would need to have to collect loads and loads of data. So many data. We never will be able to achieve that. And so that's why these simulations that are already being done, they are always like really rough estimations. Yeah.
Thank you very much. So I understand that each situation and each case, even of this problem, is unique, and it needs some additional and deep study. Thank you very much.
Exactly. Yeah, we need so much more data. We see. Yeah, we definitely need that. Yeah, that's why I always say to everybody, you need to put at where you are in your port or whatever, have a baseline study running. Yeah, that's what I actually wanted to start as well with my project partners. Yeah, and that they continue that. They have got now the basic equipment to do this, and so they can basically continue now to find out what happens in this place. Yeah. And if we get enough places doing this, then we can put that together, and then somebody can do fantastic models about that. Yeah. But without these background data, we will never get to that. Yeah.
Thank you.
Yeah.
Thank you very much.
Yeah. No, but thank you for your question. Yeah.
Okay, we have Elsie. Gansia. Sorry again for the destroying of your name. Elsie. So maybe she can't unmute. So are there opportunities for collaboration or research projects between industry professionals and maritime students to explore innovative anti-fouling solutions?
This is exactly what we want to do with the network. But for that, we need to have a big network. Yeah. So sign up and we can do it.
Yep. Yep.
Yeah, exactly. We are totally for that. Yeah, absolutely.
Absolutely.
Yeah.
And then Sankalp also helped with the answer about the thickness of the biofouling, suggesting that perhaps some sensor-based data could be used to help measure the thickness of biofouling using AI or existing data on similar vessels and their characteristics.
Yes, exactly.
That would be very interesting and exciting to get going if we could get all that data together to train something like that.
Exactly, yeah. And get some engineers together to develop that further. Yeah.
Yeah, absolutely.
Exactly. Yeah.
And possibly the final answer question, because I see it's after 1 already. Can these presented options be applied to ships traveling all around the world, or do we need specific things for various places, such as the Arctic and the Antarctic?
In terms of
the possible new solutions.
I don't know solutions. Okay. It will be solutions for anti-fouling are actually always depending on the where the ship goes to. Yeah. And because obviously tropical areas have a different biofouling load from more cold temperate. Yeah. So again, I think there are already separate coatings sometimes for that. And so it depends on what you have in mind. You see, we presented so many different things there. I mean, some are rather specific. If you go back to the Selectope there, where they have data for barnacles, which is very efficient, but we don't know what happens there with algae, for example. So it will again depend always, where does your ship go to? Yeah. And that's how you design your anti-fouling solution. It will be always a combination of different things. Yeah. It will not be just one solution. It will be a combination of solutions that work together. I hope that helps. Yeah.
And just to squeeze one last question, just because it's very useful for this point, I think. Someone was asking, how can we be part of the network?
Okay. Yeah. So do you see that slide there that I currently have on there? It says email us at iamunu@ljmu.ac.uk. Email us there, and we put you in the biofouling network. That's all you have to do. So you just need to email telling us, I want to be a member of the network, and you will be a member of the network. We will be collecting your name and your university, and then also your email address. Yeah, so we're looking forward to see you there. Yeah. Iske, how is it? Do we continue, or what do you prefer?
I mean, it's a good timing for closing the webinar because
Okay.
it's exactly the 1 hour pass.
Good. So yes, yeah. So I just then at the end then basically thank you for all coming here and being so interested in it. So we are at the end now, and we're hoping that you found that really informative. I think you did, and you will actually see us again if you want on the 14th of May. That will be the next webinar. This time I will have the next to me, not Bogdan, unfortunately, but Özkan and Yasin from Turkey. Yes, that will be different, will be fun, and as well. So that's our next webinar, and it's actually again a different topic. And please also leave us some suggestions for topics that you would like us to talk about. So therefore, there is a little survey now directly after that when you close. Please fill that in. And we are very keen to hear what you think about it. And please email us with this email address that you see to become a member of the network. Yeah. And other than that, thank you so much. Be biofouled, and yes, and have a good weekend. Yes. Okay.
Thank you very
So
much.
from all of us.
Okay, thank you very much.
Yes.
Bye-bye.
Thank you very much.
Thank
Bye
you.
bye.
Bye bye.
Bye
Bye-bye.
bye.
Thank you very much.